I'm Frank. I work at, what does it say? I work at Google, where I work on Firebase. I'm an engineer there. Yeah, we are right out here. You might have seen us. If you've got a headband, you have some of our swag. We also brought shirts, hot sauce, stickers. We brought David East, our new internet celebrity. So he's going to be awesome. And we're here to tell you a bit about Firebase. So I have 40 minutes for this talk, which is not a lot, so we better get started quickly. And we're going to be talking about how to build apps with Firebase. So in this talk, normally these talks write lots of slides, lots of people boring you with bullet points. I don't really like bullet points. So I have a few slides, and then we're going to go to coding. So I'm going to code an Android app from start to finish, fingers crossed. And if you liked what you see, then at 2:30 we have a code lab. It's right across the hallway here. And then you are going to be live coding an Android app. So that's going to be awesome. So do join that one. A bit about Firebase. Before I start the coding, let's set some context here. So Firebase is made for a multi-device world. So nowadays we all have multiple devices, and whenever we have the same app on all of those devices, we expect that the app works together on all these devices. So if I make a change to my data on one app, I see it on the others. Think of this as like the Google Docs nowadays, right? And this is great for me as a user. I love it when in Google Docs, when I have the app open on my desktop and on my phone, if I make a change, I immediately see it on the other screen also. I love it as a developer or as a user. As a developer, I know that there's complex infrastructure behind this. And so in case you don't realize it, this is a Google data center. Most people think you can see that from the color of the wires. Actually, you can mostly see it from the fact that it says Google Data Center at the bottom. But this is what is behind something like Google Docs. Right? There's complex infrastructure behind these applications. And this is fun for us as developers, but our users don't care about it. The users care about the features that you put in the app. Right? In modern lingo, they care if they can swipe left or right. They don't care about your beautiful databases. So with Firebase, we allow you to focus on building your app. So we are a platform that sits behind your mobile and web applications. A few of statistics, we have about 400,000 developers registered. We have about 2 million devices at any moment connected to our servers. That last number I'm not sure of, it seems very low. I'm quite sure it's higher. The other one I'm pretty sure of. And just in case we're not, let's have a look at it right now. So Firebase is part of Google. We're part of the Google Cloud products. And at the bottom of this page, you can see the number of registered developers. This is a live counter. So if you sign up, this counter will go up. Who here has already signed up for Firebase? Yeah, lots of hands are not up. So I sort of expect that you're going to sign up now and that the counter goes up. Anyone? OK, it's OK if we don't, but it is a live counter. The rest of my talk is explaining how this counter works, by the way. So we have three main features. We do a real-time database, we do authentication, and we do static hosting. I'm going to be focusing most on the real-time database for now. So who has done in the past a relational database? Good, good, good. Recently we were at a talk where not a lot of hands went up. That was scary. So who has done anything with NoSQL databases? OK, good. I might need your help explaining things to the people that raised their hand initially. So just so you know, NoSQL databases are very different. In the case of Firebase, we are a cloud-hosted hierarchical database. That's a lot of words. We are a JSON tree in the cloud. So who has worked with JSON? Yeah, he's a great teammate. So we are a cloud-hosted JSON database. Remember this slide? We all have multiple devices. If we install the app on all of these devices, we expect that the data between all of these devices is synchronized. Firebase makes this possible. So we are an online hosted database, and we automatically synchronize the data between the devices. That means that when any of these devices makes a change to the data, that change is instantly synchronized to all other connected devices. So within milliseconds, the data shows up on all devices. Now, by itself, this is not magical. What makes it magical is the way Firebase does that. So let's have a look. Like I said, I mostly do code for a living. So we're going to be live coding an Android app. So it's sort of the world's ugliest or world's smallest Android chat app. So it's not going to be pretty. as a trade-off for that, I'm going to be coding it from start to finish. I don't copy snippets. I don't do weird expander type things. Everything's going to be live coded. I do need something from you in exchange. If I make any weird typos, shout them out to me very loudly, because otherwise we're going to be here for a long time. Okay. Firebase Databases are cloud hosted, which means that I can access them at a URL. So at the bottom here, you see a link. I'm actually going to open it in a different tab. Oh, I already did that. That's not fair. So this is a Firebase database. This is the dashboard for Firebase that we see here. Let me zoom in a bit. So this is a JSON tree, and we visualize it for you. You see in here that I have 3 top-level nodes: chat, DPE, bug bash, whatever that is, and messages. I have 3 different applications in a single database. And we're going to be working with the chat application today. So I click on it and I zoom in. If you pay attention, the URL in the address bar changed because of that. So I had nanochat.firebase.io.com. I now went to /chat under that. Every element in my JSON tree is uniquely addressable on the internet. That means that if I go to this single chat message here, the URL changes again, and I only see that one. If I only want to see this string has its own unique address. So every value in your Firebase database is uniquely addressable. It's one of the unique points we do. Firebase has many SDKs. So we have an Android SDK that I'm going to be using in a minute. We also have a JavaScript SDK, an iOS SDK. And if those don't work for you, we have a REST API. The good thing about the REST API is that I can show it in a browser. So if I type .json at the end of the URL, I get the JSON string that's at that location. So this is the entire JSON data at this location. This is for those with REST, this is a GET request to this endpoint. And I can also do put, post, delete, so I can manipulate the data that way. Let's go back to the regular view. So this is the database we're going to be working with. Let's actually move it a bit to the side and start looking at the actual code that we're building. So I have an emulator open. And I have, and that one rebooted. Earlier today, my entire machine rebooted. That was fun. I hope that the Android emulator comes back up. While we're waiting for that, let's look at Android Studio. So who uses Android Studio for the Android work? Good, good, good. If your hand isn't up, what are you using? Let's create a new project. So I call this NanoChat because it's like the minimal chat application I can build. Next up, we need to select the SDK that we want to target. So Firebase works from API level 10 and up. I never remember what it is, but something Jelly Bean, I think. And that means that we work on 99.7% of the devices. In this case, I'm targeting API level 16 because we have a library that requires this. We're still targeting 95% of all Android devices that are on the Play Store. I'm going to create an empty activity. Let's call it main activity. While this is generating, you'll see that my emulator came back up, so that's good. One of the disadvantages of live coding this app, by the way, is that we're going to be waiting for Gradle for a bit. I will try to fill the time with popular songs, but I hope Gradle is fast because I'm not really a singer. So. Ooh, that doesn't look good. Let's not file a bug report. So I'm on Android Studio 2.0 Beta 6. That might explain a bit. Make this a bit smaller. Let's see if we can fit everything here. Okay. So Gradle is still, or Android Studio is still indexing actually. That takes a bit of time. Once that is done, this should also work. Not sure why that one popped up. Who, by the way, is already using Android Studio 2? Yeah, I like the way you dare. No, it's a lot faster on Android Studio 2. It does have its stability issues, of course. It's in beta, that's the reason for that. Are you already using Instant Run? Oh, yeah, when Instant Run works, it's awesome, by the way. It's really great. The problem is that it sometimes doesn't work, and then you're wondering what happened. OK, we're back in the code. So this is my layout. I'm going to build a layout for the chat application. If you remember from the screenshot, we had at the bottom a text box and a button, and at the top we had a list of messages. So let's build that. It's going to be a bit tiny, but otherwise things won't fit. So I'm quite sure nobody uses this designer in the way I do, but in a demo it sort of works better this way. Oh, let's get rid of that text view. So this is going to be my footer. So let's call it that. We're going to add a button. And the button is send, so it's a send button. Oh. I expected people to shout out my typo, but okay. And then we add a text box. It's a bit of the tricky one. Normally, it needs to be on the left. So this is where I add my text message that I'm going to be sending to the chat. So it's going to be called message text. We're going to make the footer wrap the content. And then we're going to add a list box, a list view. So of course, in real Android projects nowadays, you would use a recycler view. But it requires 5 lines more code. And that just doesn't make it fit on my screen. So for the demo, I'm going to use a list view. Like this. And in here, I'm going to show the messages. So let's call it messages list. Cool. That's all we need for a layout. Next thing you would probably do with Dagger. In this case, I'm actually going to type these. Oh. So that's my send button. Yeah, it's going to complain about that and then offer it. By the way, I said I was going to not copy anything. I rely on auto-completion a lot. Yay, Android Studio. Message text is what I called it, I think. So that's one, and then we had a list view with the messages. Almost done. Then we'll get to the interesting part. Okay, good. So remember that I showed you the chat application that we're building. You see it here on the left. I'm going to make it slightly smaller so that we can see it slightly better, I hope. So we see that we have a list of chat messages here. In this case, it's a list with only one chat message in there at the moment. And the chat message has 2 properties. It has a property name and a message. So the first thing I'm going to do is, since Java doesn't have any way to represent this JSON data, I'm going to create a class that represents it for me. So I'm going to create a tiny class that has 2 properties, name and message. If you've ever done Java beans, this is going to be quite familiar. We're going to generate a Java bean class for this. Let's call it chat message. And it has 2 properties. It's important that we spell them the exact same way as they are in the JSON, because that way Firebase can automatically map them from the JSON to the Java class. So I had a string name and a string message. Now it needs to be a Java bean, which means that it needs an empty constructor. So let's do that first. Then it needs a constructor with both parameters. That's not needed for a Java bean, but it's needed for my own code. And then it needs 2 getters, so let's generate those. Code generation is fun. Okay, so this class now represents a chat message in my, from the database in my Android application. Let's go back here. It's about time that we start using Firebase here. So to enable Firebase, we open the module settings. And in there, there's these developer services nowadays. We have cloud, and there's a Firebase checkbox. This does 2 things, and you can just as easily do them by hand, by the way. So it adds a dependency to my Gradle file, and it adds the internet permission. So that's all that we did. There's some more instructions that we need to follow, so let's open those. I'm going to click OK here. And while that is compiling, let's look at the instructions. So if your hand didn't go up when I asked if you have a Firebase account, if you want to take the code lab, go there now and sign up. It doesn't take anything. You need a Google account. We don't need credit card details. You don't need to pay us. You just need to have an account with us so that you have a database. So I already have one, so I'm going to skip that step. Now apparently I need to fix the Gradle build. We're working on actually fixing this in the actual code itself. Let's go here. I need the Gradle file after all. I'm going to add this here. Now, I had something weird yesterday with the build problem, so what I'm going to change is I'm going to actually change to build version 23. I didn't have time to fix it, so I'm going to do that now. Okay, while that is synchronizing, we're going to go back here. Let's have a quick look at the documentation again. So we fixed the Gradle build. Next step is that we're going to set up Firebase on Android. I lied a bit when I said I'm not going to copy-paste anything, because this one I'm going to copy-paste. Currently, we're still synchronizing. It should almost be done. There we go. Okay. So this initializes Firebase for use in this Android app. It tells Firebase where to run, essentially. That's all. After that, the instructions say that we're going to read and write to the Firebase database. I'm going to type this myself. I'm not that lazy. So we need a connection to the database. We're going to do that by creating a new Firebase class, and we typically call these ref for reference. So this is a reference to data in the Firebase cloud. New Firebase. If you've done anything with databases, you're probably used to having a connection string, right? I mean, these might be SQLite paths, they might be ODBC or JDBC connection strings. In the Firebase case, they are a URL. So I take the URL and I paste it in here. So this contains everything that you might be used from other projects. This is your API key, it is your project ID, it's all in one go. Essentially, NanoChat is everything that we need to know for this. So my database is called NanoChat, yours will be called something different. So this creates a connection to the database, then we're pretty much ready to start sending a chat message. So I have the send button, and if I now set an on-click listener to that, then I can start sending a chat message to Firebase. Remember the class that we created? Let's say that we do new chat message. And now this takes two parameters. One of them is the name. I'm going to hard code the name. If you take the code lab at 2:30, you're going to actually replace this with a real logged in user. But for the demo now, I'm going to hard code it. And then I need the chat message. So that's in message.txt.getText. Let's do a toString on that. Now I need to send it to Firebase. Remember, we have a list of chat messages. We are connected to this place in the list. So what I'm going to do is I'm going to add a new chat message and then send the data to it. So to add a new message, we're going to do ref.push. If you've ever used arrays in JavaScript, it's very similar. And then I'm going to set the value there to my chat message that I just created. Ref needs to be final. This is all that it takes to set data to Firebase. If you've ever done any networking code on Android, it has never been this simple. I'm not checking for network connectivity. I'm not handling connectivity loss. Yes, this will work. I'm going to do one more thing just because I think it helps me, is I'm going to clear the text box. That's mostly so that I know that I actually clicked the send button. Okay, let's compile this and see if it works. I'm going to run it on my emulator. This is Gradle, so it takes a while to spin up. It shouldn't be too bad, but I'm running this on a MacBook Air, so if you have a better machine, it probably will be a lot faster. For me, it normally takes about a minute to run this. What we'll have then is that we'll have the sending of messages from my Android app to a database. Like I said, if you've ever seen an API that makes this simpler, please drop by after my talk. I want to hear about that API, because we'd love to make it even simpler. So what we're going to be doing is we're starting the chat app. This is still the slide, by the way, in the background. And we're going to start the chat app, and we're going to send a name and message to the database. It's almost done. It's now installing. I like having them side by side. Let's actually make the emulator a bit bigger. This is, by the way, a 2.0 emulator, which is probably the reason my machine crashed this morning, but it's also nice because I can finally resize it by dragging. I'm quite sure Chet and Romain got huge applause for that this morning. Okay, the app started. So now we can say hello from Android. If we hit send now, it shows up in the database automatically. I'll hold for applause at this moment. Thank you. Wow, you guys are nicely following along in that one. Thanks. What? I have a typo? Yeah, I do actually, true. Just like this morning in my tweet, apparently. But so this is sending from Firebase. Now let's actually get the messages from the database into the Android app. We're good on time, so I'm going to do this the hard way. So we're back in our code. We have a list view. We need to populate the list view with data from Firebase. Not sure how you populate list views, but normally this requires that you use an adapter. So let's create an array adapter of chat messages, of course. And then apparently I need to fill in this constructor. Let's do that first. Wow. So this takes a few parameters. It takes a context, that's this. It takes a layout. So I'm not copy pasting. I am secretly stealing this from Android's built-in layouts. So I'm not sure if you know, but there's a few layouts built in. They've been deprecated since API level 16, but I still use them. So this is a two-line list item. It has two text views. And then it needs to know the messages that it's going to display. So I'm going to have to populate a list of messages some way from Firebase. Let's do that like this. Okay. Those are the arguments. Of course, I don't have the messages yet. So I'm actually going to create a local variable. And it's going to be a list of chat messages like that. We got that. I'm not going to populate it yet, right? There's nothing that takes them from Firebase. Let's first actually make sure that the messages show up in my view. So I'm going to override a few things. Well, actually, I'm going to override one method, getView. I recently had to explain this to a teammate of mine, and it was very confusing for him that you explicitly have to override getView, but it is needed, though. Okay, we get a few things here. We get the position that we need to render, and we get the view that we need to render it into. Now that view might, of course, not be existing yet, so in that case, we need to create it. So view is get layout inflator dot inflate, then again the same view as we had before. Needs a few more things. Needs to be to the parent and needs to be detached from everything else. So now we have a view and we can populate it. So to populate the view, we're going to find the children, and since this is a very generic view, they're called text1 and text2. Not very good in a real application, but this is what we need here. Okay, what am I going to set in here? I need a chat message, right? Remember, I have the list of messages, so what I'm going to do is I'm going to get the chat message from that list of messages. And it's at position, so I'm going to use the position there. Then I'm going to display the name. Like that. I'm going to duplicate this line, and then text2 is going to be the message. Does this make sense? Okay. Then I need to return the view. And I need to bind the adapter to the list view. I always forget this step, so I'm quite proud that I remembered it this time. Of course, I make up for that by making another mistake. This is pretty much what it takes to get data from Firebase into an app. Hold on. We didn't yet get the data from Firebase yet, so let's do that next. So Firebase allows me to listen for data. So Firebase, right, for other databases, you might be used to a request-response model. You fire a query against the database, it returns the data from the database. Firebase is really different. We synchronize the data. Remember that animation that I had? That means that I need to keep listening for changes to the data. So Firebase doesn't work with a get data and you're waiting for the response. It works with a listener. So I have the Firebase reference. I'm going to add a listener. And in this case, I'm going to add a child listener, which means that I get notified whenever a child is added or removed under chat. So when I add a new chat message, the Firebase SDK is going to tell me about that new chat message. Let's do that. Now this generated a lot of code for me. There's all kinds of events that can happen. In this case, I'm only going to worry about onChildEdit for the moment. So onChildEdit, I get a snapshot of the data at that location. Now this fires for both the initial messages and for any chat message I add later. So this is great because for my chat application, it means that when I first start the app, it's going to connect to Firebase and it's going to get 2 onChildEdits because I had 2 chat messages straight away. Then when I add a new message, it's going to get the next one. So, and I get a snapshot of the data at that location for the new chat message. So let's actually get the chat message out of that. So we have getValue, and then I'm going to say, give me the value for a chat message. Remember, we just sent a chat message to the Firebase database, and then Firebase took the properties from our Java bean and posted them to the database. Now we're getting it back. And then I'm going to add it to the list. I need to do one more thing. I need to tell the adapter that the data has changed. So I do it like this. This is what we need now. Of course, we have these other methods. I'm going to ignore them for the moment, and I'll show you why that's a bad idea in a minute. So let's start this on the emulator again. So we have 2 chat messages, and we have the emulator. Gradle is still spinning, so nothing's showing yet, but it should be done quickly. It's bouncing there. I hope it's not showing error messages, because that sort of messes up the demo normally. Ah, I did. Why, oh why, Android Studio, can you not autocomplete a semicolon? Let's try that again. Okay. Wow. Does anyone notice? Is it spinning? Is it doing anything? Yeah, okay, it's happening. I normally like showing the emulator straight away because then you can see that the application loads and it connects to the network and it gets the data from there. So, okay. So now we have 2 chat messages. So David wants to give a round of applause for that. And since David is our in-house YouTube celebrity, we really must listen to him. So. Okay, this is awesome because now I can say hello again. And I can send it. And it shows up on here, but it also shows up in my application straight away. Let's have a quick look at something. Because chat is not fun if you're on your own. So what I'm going to do is I'm going to open the developer tools here. I'm going to do the exact same thing that we had before. But now I'm going to do it from JavaScript. So I'm going to create a reference to the new Firebase database. Or to this Firebase database. Remember that it's a URL, so I'm going to do it like that. Exact same code as we had in Android, except that it says var instead of Firebase. Now remember, we add a message. So we're going to go ref.push.set. In this case, it's not called set value, it's called set. I'm going to send a name, or set a name. Let's call the user Chrome. And the message is going to be hello from Chrome. Now if I hit enter, the message will be added at the top, and it will also be added to my Android app. So with this, we have a cross-platform multi-user chat application. Okay, I didn't build the GUI. I didn't really stuff my JavaScript into a file yet, but the code is there. One thing I notice is that it only just fits. I don't sort of like that, so let's see what happens if I remove a chat message. Let's remove this one. So now the message gets removed from the database. It shows in red. But it doesn't get removed from the Android app. Who knows why? Good, you're following along. I like that. Yeah, I didn't implement onChild removed. You notice that there's a lot more going on here. We have onChild change, onChild move. We have this extra argument that we're ignoring. It's a lot of work to make this work. So what we've done is we create a library that handles most of this for you. That library is called Firebase UI, and we're going to replace most of the code with that. So let's go to my module settings again, and let's add a dependency. Again, you probably do this in your Gradle file. I do it through the GUI for now. So Firebase UI is the library. We're on 0.3.1. And this is a mobile binding library, so it simplifies the work. I've showed you how to do this manually if you feel like it with your own code. Now I'm going to do it automated. So Gradle is synchronizing. We're going to get rid of most of the code that we just wrote. So this onChild listener thing, it's not needed anymore. So let's get it out of there. Then we have this adapter that we display here. I actually don't need that for the most part. What I do need is these 2 lines, because we still need to populate the view. So let's cut those 2 lines. Let's remove everything else. I still need to set an adapter, and I still need an adapter, of course. So what I have is a Firebase list adapter. This comes from the Firebase UI library. It's, of course, a list adapter for chat messages. So almost the same as before, except that it auto-populated a method for me. I still need to populate my constructor parameters. They're pretty much the same as before, but slightly more. So I need an activity. I need a model class, so that's chat message. Oh, that explains. That's class. I need a layout. Remember, we were using Android.r line list item. And I need a reference. I can just type ref in here, which is all the Firebase data at that location. But to make it slightly more fun, I'm only going to show recent messages. I still need to create this. I quickly want to do one thing, because otherwise I'll lose my clipboard. I'm going to paste the code in here. It's the exact same code that we had before. But now that's the only thing we need here. So let's show only recent messages. So before we were showing all the messages. Now I'm going to show only the recent messages, which is a Firebase query. And it's actually based on the reference that we already had. But now I'm just going to say limit to last 3, because that's what I could reasonably fit on the screen here. But this means that this Firebase list adapter will synchronize 3 messages from the server. So right now, we had 3 messages, I think, so it will show all 3. If we add a 4th message, it will automatically remove the first one. If I actually remove the last message again, it will re-add that one back. This is it. This is all we need to do a chat application with Firebase and Firebase UI. If I used a slightly smaller font, it would fit on a single screen. Let's see if this runs. It seems to be doing okay with that. So it's going to restart my application now. Right now, the result should be oh, actually, we already had 4 messages. No, that was still the 4th message that shouldn't be showing. I was getting concerned there. So it should show the 3 messages that we had before. Nothing changed except that I threw about half of my code away, the code that was difficult. But now I can send a message again. Now if I send it, notice a few things. We have a 4th message here now, but my first message disappeared from here. That's handled automatically for you. Because when the new message is added, we get an on-child added for the new message. We get an on-child removed for the previously first message that we now need to remove. So everything happens automatically for us because Firebase List Adapter handles that for us. If you want to see the Firebase UI project is open source, you can just see what we do there. By all means, copy the code. It's there for you to use. It's sometimes tricky to get that code right. That's why we wrote it for you. This also means that if I actually now remove a message from here, that it will update on the right and we get our message back. So everything happens automatically. You can do fun little things with that. I lied a bit. I did do a snippet just there. You can reorder these messages. That means that they're now being reordered dynamically, and it's also updating in my Android app. It's a great way to unit test code, we found out, by the way. Okay, this is an Android chat app in, let's see, probably about 50 lines of code. It's as easy as we can make it. So you had to suffer through the code. Now we're back to slides, and we all know how you like slides. So if you like this, oh, I forgot one thing. We handle offline very well. Remember when I said you don't have to detect if there's a network connection? You also don't have to detect if the network connection disappears. So Firebase keeps in memory a cache of all the data you've already gotten from the server. If you send a new chat message, it will show up in your screen straight away, but it will actually be queued. So if there's no network connection, it will be queued for writing to the server. So that means that we keep everything in memory. And when you come out of that tunnel, it's automatically synchronized to the server and synchronized to all other connected clients. So you don't have to write any code for that. The code we just wrote already does that for you. What it doesn't do yet is disk persistence. So what I just said is like the app stays active. We do have a command that writes it to disk. It's a one-liner that you add. Then we save the data to disk also. And that means that you can also handle airplane mode. All of that is literally doable within what I just showed, 40 minutes. That's the real-time database. We need to cover a few topics yet, because nothing I showed you so far was secured. I have a few validation rules on this database. I didn't sign in. That means that any one of you could have gone into my database and added chat messages. Normally when I do a web version of this, somebody does. And that's not what you want. So you need to secure your data, and to do that you need to know who your users are. So that's Firebase authentication. That's our second big feature. I'm not going to spend too much time on it, but we have 3 types of authentication. We do email passwords, and if you go to our code lab, you're going to wire that one up. We do social providers, so you see them here, Google, Facebook, the usual ones. And we do a custom backend. So if you already have a database of users, you can use your user database, authenticate the user, and tell us about it. And that allows you to secure the data. So the authentication is handled by us, and then you can authorize that user to access, read, or write specific parts of the database. That's how you secure a Firebase backend. On the web, this is trivial. On Android, this used to be quite difficult, but we recently released a new version of our Firebase UI library that includes the UI for signing in with all these providers. So you see it here. The screenshot on the left is from Android. The one on the right is from iOS. We have this library for both Android and iOS. They do the same. And so you can see that we handle all the social providers. All you need to do is provide us with the keys. You enter them into the Firebase dashboard that we saw earlier, and then you're good to go with this. Again, the code lab is going to talk you through that. Yeah, quick bit about authentication. So this is the code that you would need if you're not using the library. It's authenticating a user with a password. Who knows Bob Tony and correct horse battery staple? Who knows what that's a reference to? Tell me. Yeah, it's from XKCD. where it explains that a long password nowadays is better than a complex password. So, by the way, a long password is better. This long password is probably the worst one you could pick, because I'm pretty sure it's right in all the rainbow tables after secret, password, and something else. So, this is how you sign in. Two things can happen when you sign in. This is on Android. It either succeeds or it doesn't. If it succeeds, you get a little bit of auth data. And in there we have the UID, the user ID. That means that we can now identify Bob Tony. And that's great because that means that we can also make sure that Bob Tony can only post to chat rooms that he's a member from or stuff like that. And the good thing there is that this UID is going to be persistent. So if Bob Tony signs out, signs in again, he's going to get the same UID. If he installs it on a different Android device, same UID. Or even with a web application or an iOS application, Bob Tony will still be identified as the same Bob Tony. That's Firebase authentication. We also do static asset hosting, which is great if you're doing web development, but we don't because we do Android. So these are the three main Firebase features: real-time database, user authentication, and static hosting. If you like this app, if you want to build an app like this, keep in mind, nothing I showed you today from Firebase is chat. It's just a database. I happen to model a chat application in it. If you like that, go to the code lab and you will also build that same chat application. It takes about 40 to 50 minutes. You will get something working by the end of that time, I guarantee it. The only thing you need is Android Studio. If you don't have that installed yet, you have about 20 minutes and the Wi-Fi here is pretty good. So you should be good by the time we start the code lab. Abe is actually teaching that code lab, but I don't see him right now. Oh, he's sitting over there relaxing, so that's cool. But that's just one type of application. Since this is just an online database, whatever your mind can dream up, you can build on Firebase. If you've taken the code lab and want to learn more, we've released 2 months ago a course about Firebase on Udacity. And it's Firebase Essentials for Android. It's free, like all Udacity courses. You can take the course for free. It's about 5 lessons, and it takes you through everything you need to know to build an app for Android with Firebase. So they're building a collaborative shopping list application, so not a chat app. And that means that users sign into the app, they create a shopping list, invite their roommates to also be on the shopping list, they add items to the shopping list, go to the store, check them off, right? And just like with everything else in Firebase, whenever one of them makes a change, all those changes are synchronized to all other connected devices within milliseconds. Quite important. So you see that we have the data tree on the left here. That data tree is a bit more complex than what you've seen before. So they also teach you NoSQL data modeling. It's fun, they actually make a mistake in lesson 1 that they then fix in lesson 3. And I make a mistake in lesson 3 that we tell you at the end that you really shouldn't be doing, but we don't fix it. So, but it's a great course. It's set to take about 40 hours because you are going to be programming the application. So at the end of this, you will have built, so you will need to know Android development already. So the Android development course is sort of required for this. But at the end of this, you will have built a complete app that actually could just go into the Play Store. I expect a lot of shopping list applications in the Play Store in the next year. So. It's taught by the Udacity teachers. So the girl with the green hat on the couch is Lila. She did Android beginners, and she also does this one. The guy with the red hat is JP. He's a Googler. And he explains most of Firebase, and he's really good at explaining Firebase. He also talks a lot slower than I do, so that's good. Like I said, they explain NoSQL. It's for free. If you just search Firebase and Udacity, you're going to find it. Leads me to the code lab. So remember to go there. It's in 20 minutes. It's in the code lab space over there. We have tons of space. We have lots of people available to help you. We'd love it if you show up and write a chat application with us. That's pretty much all I have. So if you have any questions, just ask me. I have probably about 5 to 10 minutes for this. I'm checking if somebody's signaling that. Otherwise, you can always reach me on Twitter. I'm Puff, or you can follow us on Firebase. I have some short links here, but to be honest, most of our stuff is easily findable if you Google for it. So, any questions? Tell me. Cool. Love the question. Let me repeat it. So Firebase handles offline, and right when you come back online, we synchronize everything automatically. And in chat, it's important that the chat messages arrive in the correct order, and they do. So I'm not sure if you noticed we had that very weird long key in there. It started with dash and then K. Those are not your regular array indices. Those are Firebase push IDs. And the push IDs are generated on the client, and they allow us to do 2 things. One, if we would use array indices, then if we are chatting and we had 3 messages in there and we are both typing, then whoever hits send first is going to be the 4th message, right? and then the other one is going to be the fifth. So we need to agree on the number of messages, which is horrible for concurrency, right? This is going to be a contention issue. So that's one of the reasons we don't use array indices. The other one is that array indices would never work offline. So this key is generated client-side, and it consists of the timestamp and some random junk to make it unique. It's essentially like a UUID, except that it's ordered. The timestamp is corrected for your offset to the server when you were last online. And that means that we actually have a pretty good idea who hit enter first, even when you're not online. So when you get out of that tunnel, the messages are still merged together in the right order. This is pretty important with Firebase. We tend to recommend conflict avoidance and not conflict resolution. This is conflict avoidance, essentially. These keys are guaranteed to be unique. So. Okay. We quickly check the clock before. We're good. Go ahead. Mm-hmm.
And you decide later on to add a timestamp to each
chat
item. I assume the new ones going up will then have that in JSON, but then when it's trying to pull down the old ones and translate them, is that going to break it?
Good question. Let me quickly repeat. So the question is, how do we handle if you are adding properties to the database? On the web, this is easy because JSON is very relaxed about these things. On Android, this is slightly more difficult. So API versioning, as this is known, is something you definitely need to consider. What you would do here is either you need to migrate the data over, which is just a matter of looping through it and adding some value for it, or you need to handle it relaxedly in your Java bean. So you can add annotations there that say ignore those properties or write them back. But this is something we are aware of, and we are constantly looking at ways to improve this, because in Android and iOS this is more difficult than it is on the web. So I saw a few hands going up here. I'm first going to go. Over there, apparently. Tell me. No, it's a great question. So the question is if we have support for push notifications for when the app is not active. So we don't have support for that built into Firebase. I'm actually quickly going to run up so I can show you something. So we work only when the app is active, or when you put us in a service. So we need a connection to the Firebase server. So we keep a socket open to the server, and that's the way we can get that instant feedback. And that's, of course, great for when the app is active. And you could even put us in a service, then it runs in the background, but your users are not going to be happy because we're going to drain the battery. So that's not a good idea. But we don't have anything built in. If you look 2 tabs to the left, you're going to see sending push notifications. I'm working on a blog post that describes how to do this. It should be out soon, but I sort of got distracted by preparing for this talk. So I'm going to come down again, start asking. Sorry?
If we have different users and we need to talk with them, do we need to subscribe to different channels or something like that?
Yeah, so what I just showed you, sorry. So the question is, how do you handle if you have multiple users and how do you talk to them? So it's a typical scenario where you have multiple chat rooms. So what I just showed you is there was one chat room, but when I showed you the database, there were 3 different top-level nodes. I had chat, DPG, bug bash, and messages. Those are actually 3 different chat rooms, essentially. They use a slightly different format. So you would model the users into chat rooms. So either by doing opt-in chat rooms, like named chat rooms that you would know from Slack or something like that, or you could even model one-on-one chat rooms, for example. We see that quite a bit. Remember that we have the user ID? If you and I are chatting, then I could just concatenate your and my user ID together, and I'd get a key that uniquely identifies that it's us chatting. And it's repeatable, so I don't need to do any weird querying for it. As long as you and I get the same UID, we're going to be in the same room. That's how we recommend modeling user-to-user chat rooms. Okay. Our timing is great, guys. Okay, I'm going to wrap up here because we're sort of out of time. I do have time for your question, but that means that I'm going to kick everyone else out, if that's okay with you. Okay? Thanks for your time. Thanks for your attention. Again, go to our code lab. It's going to be fun. We're going to have tons of fun over there.